This video is about solving a system of two linear equations by elimination. The goal of elimination is to cancel one of the variables by adding a multiple of one equation to a multiple of the other equation in the system. I've outlined the steps here. First one is get both equations into the form ax plus by equals c. So we need to have both equations in this standard form before we can start solving by elimination. Step 2, choose a variable to eliminate. So this is going to be a choice, and you can usually find one that's slightly easier than the other. If not, it doesn't matter which one you pick. You can eliminate the x or eliminate the y. Once you've chosen, multiply each equation by a constant in order to get the same number with opposite signs in front of the variable that you want to eliminate. Add the two equations together. At this step, the desired variable should cancel. Then you solve the resulting equation for the remaining variable, be it x or y, whichever one is left. Plug the value of the remaining variable that you found into either of the original equations to solve for the value of the other variable, and then check your answer by plugging the original pair into each original equation. This is important, the original equation part, because that will catch any errors that you may have made along the way. Let's look at one example. We want to solve the system 6x plus 7y equals 4 and 5x plus 9y equals 12. And we're going to use elimination. So what I do first is I'm going to write my system over here. So I have 6x plus 7y equals 4 and 5x plus 9y equals 12. Now it's a choice, which variable do I want to eliminate? And when I choose, that will determine what I multiply each equation by. So I'm going to just choose to eliminate the x. So it doesn't matter. I could have chosen y, but I chose x. So what that will do is that will tell me what to multiply the first equation by and what to multiply the second equation by. Now I want to get the same coefficient on the first equation in front of the x as I have on the second equation in front of the x, except I want opposite signs. So if I multiply the first equation by 5 and the second equation by -6, when I distribute, that will give me a positive 30x for the first equation and a negative 30x for the second equation. So now I have to distribute, and that 5 gets multiplied to every single term in the equation. Remember, when you are working with equations, whatever you do to one side of the equation, you have to do to the other side of the equation to keep it balanced. So this will become 30x. 5 times 7 is 35, so plus 35y, and then 4 times 5 is 20. So every single term got multiplied by 5. Now the second equation, I'll distribute that -6. So -6 gets multiplied to 5, to 9, and to 12. So I'll end up with -30x. -6 times +9 would give me a -54y. And then 6 times 12, or -6 times 12, will give me a negative, and that would be 72, -72. So now I'm going to add my two equations together. Notice that in front of the x, I get a positive 30 and a -30. So when I add my equations together, those x's actually cancel each other out. 30 minus 30 would give me 0x. Now I have 35 minus 54. And if you need to use a calculator, you can pull up your calculator. 35 minus 54. So I get negative 19y. So I'll have negative 19y equals 20 minus 72 is negative 52. So now I'm at the step where I solve for the remaining variable. I'm going to go ahead and divide both sides by a negative 19. And that will give me my y value. Okay, now a negative over a negative gives me a positive. So I get y equals 52 over 19. And I don't think that can be simplified, but what you'll want to do is just check. Go ahead and go back to your calculator, put in 52 over 19, and I'm going to click this fraction button, convert to fraction. So that fraction cannot be simplified. That is my final answer for the y value. Now what I want to do is plug that y value into either of my original equations. So my original equations were 6x plus 7y equals 4 and 5x plus 9y equals 12. It doesn't matter which one I pick, I'm going to plug that y value in. So I'll just go with the first one. I'll say 6x plus 7 times 52/19 equals 4. And I have to go through the process of solving this. So I'm going to go ahead and use the calculator. I'll do 7 times 52 over 19. 7 times 52 over 19. And I'll go for the reduced fraction. So 364 over 19. So this becomes 6x plus 364 over 19 equals 4. I'll go ahead and subtract the constant 364 over 19 from both sides. So minus 364 over 19 minus 364 over 19. So I'm doing that from both sides. All right, and let me go back to my calculator here. So I'll have 4 minus 364 over 19. And I'll go ahead and get a fraction there. So negative 288 over 19. So over here, I have 6x Okay, just give me 1 second here. Okay, so I want to get my black pen. Okay, so here we are. 6x equals, and we had negative 288 over 19. And then I'm just going to take both sides and divide by 6. So I'll have this side divided by 6 and this side divided by 6. So I'll just do that in the calculator. So I'm going to take my negative 288 over 19 and I'll divide that by 6 and go ahead and get a fraction. So negative 48 over 19 will be my answer for x. So x equals negative 48 over 19. All right, so I've got my solution. And now we have to think about previous lessons where we learned how do we check our solution. So first of all, let me write out my solution. My solution was x equals negative 48 over 19 and y equals 52 over 19. Now we want to check, and the way we do that is we plug those values into both of the original equations. So the first equation was 6x plus 7y equals 4. And the second equation was 5x plus 9y equals 12. Okay, so I've got my two equations. All right, so what I want to do is plug those x and y values in. So over here, I'll have 6 times negative 48/19 plus 7 times 52/19 equals 4. And over here, I'll have 5 times negative 48 over 19 plus 9 times 52 over 19 equals 12. And now I'll use the calculator to check whether those are accurate or not. Okay, so I'll do the left side one first. So I have 6 parentheses negative 48 over 19. Close the parentheses, plus 7 parentheses 52 over 19. Close the parentheses. That equals 4. So that one checks out. That one's good. Now I'll go ahead and check the second one. I have 5 parentheses negative 48 over 19. Close your parentheses, plus 9 parentheses 52 over 19. Close the parentheses, that equals 12, which is what I wanted it to equal. So you can use the calculator. You can either use Desmos or your scientific calculator or the TI-84. But what you're trying to show is that the left side of the equation equals the correct value for the right side of the equation. So since both of these checked out, that means that this solution is correct. X equals negative 48 over 19, y equals 52 over 19. So let's really quick review the steps. So what we did was we chose a variable to eliminate. We multiplied each equation by a separate number so that I would get the same coefficient with opposite sign in front of the variable that I picked to eliminate. Once I did that, I added my equations together and I only had one variable remaining. I solved for that value. To get the other variable, I plugged that value into either original equation and then solved for the missing variable. So solved for x in this case. And then my last step was checking my solution by plugging in that x and y value into both original equations and making sure it checked out. That's the process of elimination. You don't always end up with these fractions. Sometimes you'll end up with whole numbers and it will be easier to work with, but it's okay to end up with fractions, especially since you can use the calculator to help you solve like we did here.